turning turning programming, how we can create OD turning toolpath, how we can create finishing toolpath, how we can create facing toolpath in mastercam. So I will teach you all the things by serial number. So before that we have to define the machine. So here you have to select lathe and then say default. So first of all we have to define the chuck jaw and the raw material, right? So here you can say stock setup, and here you have to define left spindle. This is the left spindle. Go to the properties. Here you can give the diameter. So diameter is 270, so I have given that. Length is 230, so I have given that. And here you can define the z-axis position. So we have keep we need z0 on this position, so that is 0. And here you can define the position. These all things will be 0 because our origin is here, so all the thing will be here 0, and then say OK. Then you have to define the chuck jaw, left spindle. Go to the properties, and then you can say rectangular jaw thickness. You can define the thickness and all. And next you have to define the parameters. Here you can define the actual dia, and then you have to define the z position, where you have to keep the z position. I will keep here. So if we will keep z position here, then we will be not able to do machine of this chamfer. So we will add some material. We will move it 4 mm in minus 8 mm. So it will be OK, and then say OK. Shade boundary, so it will look like in shading mode, and then say OK. So now we have done the stock. We have filled the stock definition and chuck jaw definitions. So now we will start the programming. So before that we need curve, right? So mastercam don't require this kind of 3D model, but if you don't have 2D drawings, so you can get that solid model and you can create the curve in mastercam. So here you will get a wireframe tab. Here you can say turn profile. Just select the model and then say OK. Here you can say spin upper profile. So you can see what is the meaning of upper profile, and then say OK. So it will create a turn profile here automatically. We don't need to create it manually. So it is processing. Okay, so as you can see, this is the profile which we have created using turn profile option, right? So easily you can create this curve in mastercam also if you don't have, right? So we will change the color. So now we don't need all these things. We need only this curve to create the program. So first of all I will create a facing program. So here I will create a curve from the center point, and I will offset it. Suppose we have to create facing toolpath 1 mm from this face. So I will select that and I will give the distance. So I will offset it from here to here and then say OK. So the next one, I will go to the turning parameter. Here you will get the general parameter. So first we have to do facing. So we will create the facing strategy. We will select that, and then we will define the tool. I will select on this, double click. So if you click on the tool, double click, so you will get the parameter. Here you can define the that which insert you need, CNMG, TNMG, which insert you need. You can select here get insert, so you will get the list, CCMT, DNMG, VNMG, which insert you need. You can select that. So I will select CNMG 1204.8. corner radius I will take 0.8 and then say OK. So this is left hand tool, and next you have to define the tool number, station number, feed you can define here 0.2 or 0.1 mm per revolution. here you can give the spindle speed, so I will give 500. I will use CSS, constant surface speed, 500 to 1000, that will be constant surface speed. Okay, so next I will go to the face parameter and I will select points from this point to this point. Okay, so here you can define the entry amount, so your tool will start 1 mm above, 1 mm far from this face, so I will set 1 mm entry amount, and then you can give rough step over, so you can give 0.5 mm of depth of cut, and we need one passage of finish, so I will take it 0.1. You can give overcut amount, so your tool will move 1 if you are using 0.8 mm of insert, then you have to apply 0.8 into 2. You can set 0.8 into 2, so it will be 1.6. so your tool will go 1.8 mm down from this center point. So next we will define the retract amount, 1 mm. Stock to leave, we don't have to leave stock for finishing, we will finish in one shot in this tool path, and then say okay. So you can see we have created the facing tool path. I will show you the back plot. I will select here play, so you can see how it is moving. So we have done the facing program. So next we will create OD turning tool path, right? So first of all we will create a OD roughing tool path. So here we will select that rough, and after that I will select this curve first, and select that. We will start from this curve, and then I will select this curve as a last curve. So it will select all the middle curves automatically, and then say okay. So the next I will use the same tool. I will give the feed rate 0.2, 0.1 and spindle speed 500 to 1000, 400 to 1000. In CSS, constant surface speed, I will give the rough parameter. Depth of cut I will give 1 mm. Stock to leave in X 0.2 and Z 0.2, right? I will say don't plunge into this type of cavity area, groove type area. So we will select here blind, so it will not plunge in this area. Okay, done. So you can see we have done the OD turning tool path, but you can see there is some material. So for this kind of area we need to use button type of tool, so we can remove that easily. So I will show you that also. If you want to machine this area, then you can use VNMG insert also, so you can do machining of this area also. So if I will click here plunge parameter, you can select here. If you select here, then it will create passes for this kind of cavity, and then say okay, and then say regenerate. Let's say what's happening. So you can see it is giving tool collision with stock, so we will deactivate that, and then okay, because that area is not possible with that holder and that insert, so we will deactivate the plunge parameter from here, and then say okay. So we will create a dynamic roughing tool path for this area. So here I will show you what is dynamic roughing. This is the dynamic roughing. So I will select the partial curve from this face to this face, or I will select from this face to this face. So it will be proper area. Okay, so I will use the button type of insert for dynamic roughing. So let me find out that. So now it is showing this is hexagon, this is button tool, right? So I will use this type of insert around, and I will give the feed rate and spindle speed as per the tool, and here I will define the dynamic rough parameter. I will use 50% of step over for this area. and I will leave stock in x and z, 0.2 and 0.2. I will use plunge parameter, so I will active this area, so it will create the passes for this all area, and I say OK. So you can see how easily we have created the program for this type of area. I will play that. You can see this is the button tool, and dynamic roughing toolpath is going on. So you can remove this type of critical area material by using button tool and mastercam dynamic roughing strategy. So you can save the time, you can remove the material easily, so it will be very faster. Done. So you can see how it is easier. So I will show you the simulation. Let's see how it is working. So after that we will create the groove programs also. So I will play it here, go to the isometric view and say play. You can see this is the dynamic roughing toolpath. Actually we have done this very faster, so I will show you this again. I will make it slower. Facing, this is OD turning. So this is the dynamic roughing tool. You can see button tool can remove this material very easily and in very large amount, so we can save the time. Yeah, it's looking perfect.